On the left side of the screen, you will see the instructions that I gave you for graphing that you should have done. I gave you some data to graph. I will scroll down. I'm looking at the notes from last class. I gave you this data, and I gave you a piece of graph paper, kind of. But I think I also told you to do it in Excel, so we'll talk about Excel. So in the instructions, I told you that I want to graph the boiling point of hydrocarbons against the number of carbons in the hydrocarbon. Now, in order for you to know the number of carbons in the hydrocarbon, you have to look at the formula, and you have to look at the subscript of the carbon. So I'm gonna write right here. I'll write right here the number of carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then we have 20, and we have 30. So how do I get that? I look at the subscript of the carbon. That's 2 carbons, 6 hydrogens, 3 carbons, 8 hydrogens, etc. Now let's take a look at the rules. I am going to go over how to make a graph 2 different ways, by hand and by Excel. I'm going to go over making a graph using the rules that I gave you for graphing. These are my procedures for making a graph. All graphs should be titled. So the first thing I'm going to do is I'm going to give it a title. And the title is the boiling point of a hydrocarbon as a function of the number of carbons. That's what I asked in a title position. There's my title. Next thing it says, all graphs should have labels on the axes for the dimensions being compared. Now I told you to put the number of carbons on the x-axis. Over here, it's the boiling point. Okay. So what I'm doing right now is I'm just labeling the axes. The third bullet point says all should indicate units. Well, there's a unit for boiling point. It's called Celsius. That's the unit for boiling point, temperature. The unit for number of carbons is number of carbons. So I've already got that. I'm not going to write it again. So the title is the units. In other words, if I ask how many carbons are in propane, you say there are 3 carbons in propane. So, number of carbons is the unit. Point number 4 is the hard one. It says to make the graph as big as possible on paper. In other words, I don't want your graph on this graph paper. I don't want to see a little graph that looks like in that area. That's not what I want. I want this graph as big as possible. These are the instructions. The PowerPoint on graphing contained the instructions how to make the graph as big as possible. And it says to optimize your graph for analysis, you must use all available space. So the first thing you do is you subtract the biggest data minus the smallest data on the x-axis, and you do the same thing on the y-axis. But the point that I'm trying to make is to make your graph as big as possible, you need to know the range of data that you have, and you get that by subtracting your big number minus your small number. Okay, and then you're going to divide that by the number of lines. So let's see how we do that. Let's see how we do that. Okay, I'm going to write the range here. Now there's 2 variables. There's the x variable and the y variable, so I do this twice. So I want to include 0 for my carbons. So I'm going to say 30 minus 0, that's 30. Now, for the temperature range, I'm going to do the big number minus the small number again. It's 450 minus 164, 614. Here's my data range, 30 and 614. I am going to use the range and the number of lines to determine my spacing, my intervals. I will start with the lowest number on both scales, or somewhere near the lowest number on both scales. So for my number of carbons, I'm only going to go from 0 to 30. I'm not going to go 0 to 60. I'm not going to go 0 to 100. I just go 0 to 30. That's my range. Now, the next thing I'm going to do is I'm going to count my lines. So on my x-axis, the number of carbons, and 30 is the largest number, I count my lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. There's 23 lines on the x-axis. So what I'm going to do now is I'm going to divide my range by 23 lines. Range divided by lines, 30 divided by 23. In order to get 30 carbons, each line has to be worth 1.3. Now that is not a nice number. 1.3. How do you even have a third of a carbon? You don't want to use that. If you look at the instructions on intervals here, it says the intervals have to be nice. 1.3 is not nice. It's got to go by 1s, 2s, 5s, or 10s. And it's got to be consistent. What I'm going to do is I'm going to round this number up. You always round up. You don't round down on this. The next nice number above 1.3 is 2. So that means I can start off my graph at 0. I can go 2, that's a 4, 6, 8. I'm counting by 2s. 10, 12, 14, 16, 18, 20, 22, 24, 26, 28. Okay, so that is 30. That's my carbon scale. Now, guess what? If you count the lines going from here up to here, you'll also find it's 23. So I'm now going to divide 614 by 23. And the answer to that is 27, 26.6. That's a terrible number. I can round that number up to 30, and that tells me that if I go by 30s, I can probably fit all of my temperature degrees on that scale. The lowest number is -164. I'm going to go to 180 on my scale. Why? Because 180 is a multiple of 30, and that'll give me my 0. So if I go here, -180, this would be -150, this would be -120, this would be -90, this would be -60, -30, there's my 0, 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 360, 390, 420, 450, 480. And now I can fit all the boiling point temperatures on my scale. Now I begin plotting my data. And the instructions are for plotting the data, don't connect the dots. Do not connect the dots. The first one carbon, -164. Here's 2 carbons. So there's one, -164. That is 150. So 164 is about there. 2 carbons, I'm at -89, which is like -90. That's right there. 3 carbons would be -42. That's -30. So like around there. 4 carbons, -5. That's really close to there. -0.5. That's like right there. I'm gonna jump down here now. I'll do 12. 12 carbons is at 216. 216 is a little above it. 20 carbons, 343. 20 carbons, 20 carbons, 343. Yeah. 300, 330. Somewhere about right there. 30 carbons, 450. Right there. That's as big as a graph as I can make it. Now notice it says don't connect the dots. Now I scribbled out X, Y labels. In other words, I don't want you writing 12, 216. If you do it, good for you. I'm not going to require it this year. I'm now going to show you how to do that on Microsoft Excel. I'm going to put number of carbons. Watch what I do. I put 1, but I need to go all the way to 30. So what I'm going to do is I'm going to grab that little box. I'm going to hold the control key down. I'm going to scroll down to here, and it's going to count up to 12 automatically for me. And then I got 20 carbons and I got 30 carbons. That's the data. So 1 through 12, and then it jumped. And then I want boiling point with degrees Celsius. So let's see if I can do this. Alt 248. Is it going to let me do it? Boiling point. I'm just going to copy and paste right out of notes from the other day. I now have the number of carbons, the boiling point. I select it. I go up to insert. I go to insert. I want an XY scatter graph. Click it. I do not want to connect the dots, so don't choose that one. I can grow this a little bit. I'm going to add the element to it. I'm going to add the axis title so that I'm legal. Of course, the axis title over here is boiling point Celsius. Down here, the axis title is number of carbons. Look how easy this is once you learn how to use this program. Up here, the title of the whole graph is the boiling point in Celsius of hydrocarbons as a function of the number of carbons. Boiling point of hydrocarbons as a function of the number of carbons. I'm just about done. Here's the part that most people did not understand how to do. Right-click the data point, add a trend line, make it straight, display the equation on the chart, display the R² value on the chart. I'm going to talk about that in just a second. There it is. I'm going to move it out of the way a little bit. The R² value is kind of like a quiz grade on whether or not there's a relationship between the data. Notice it says 0.90. Consider it like a percentage. That's like saying there's a 90% chance that there is a relationship between the boiling point and the number of carbons.